Live. Okay, we are live. Welcome everyone to Decoding Coreum's ISO 222. It's a pleasure to be here with Fabio and Keen. My name is Analisa Caballero, and I'm marketing specialist here at Coreum. It's an honor to be here. I see a lot of the community members commenting on the YouTube comment section. So go ahead and do the hashtag build on Coreum, and I'll pull up your comments once we are done. So if you have any questions, make sure to write them down here. And I'm going to go ahead and leave Fabio, the head of growth at Coreum, to begin this amazing presentation.
Hello, everyone. Thank you for joining. First of all, this presentation is going to be a combination of both understanding the why we integrated or we are compliant with this ISO 202 messaging standard. And the second part, we have Keen, who's a smart contract developer from Coreum, joining us to deep dive onto how we are actually handling this compatibility, what are the possibilities, and how can smart contracts also play a role to further provide more functionality that helps institutions with this kind of transfers and settlements. So to get things started, there's a reason we're doing this live. We're going to open up the floor for questions. So if you can hear me well and you are in the chat, just leave a green thumbs up or something like that, just so we know. So nice. So Annalisa, are we ready to start? Are we waiting for more people to join, or are we good?
We are good to start. We have quite a lot of people actually watching the live. So thank you everyone for joining. We also have Keen here on stage. We have Saki Rice from the marketing team as well. Coreum Concepts. Everybody's hashtagging build on Coreum. So yeah, we're good to go.
Awesome. So I know in the audience, there's also people that might be the first time hearing what Coreum is. So I'll just do a quick intro. Coreum is a layer 1 infrastructure that we build to address specific issues and tackle specific problems that institutions are facing when it comes to adopting blockchain technology. This is one of the main features we wanted to bring with Coreum, which is compatibility with already adopted, already used financial messaging standards. So to jump into this presentation, I wanted to start by saying our vision, right? Our vision is that mass adoption won't come without institutions. And that entails Coreum providing a level of control for institutions to be able to and be confident to operate within these decentralized networks, right? I think that we've had this vision for quite a long time, even before when we built Sologenic, which I'm still part of the active team. We had this vision to always build something for long-term use, advocating for self-custody, and overall in every decision, even if it's a product decision, I think we've been careful to always contemplate security first, and also scalability and the possibility to build from something that works into something that is more complex and can be widely adopted. So our vision with specifically this ISO 222 um, integration is to address two issues in particular. One is data inconsistency. Some of the messaging that is currently used in banks, whether it's bank to bank, whether it's corporate to corporate or corporate to bank, um, we found that there's room to improve the richness of the data and just how much data we can include in messages that can still be transacted fast and can still be compliant. So in that sense, the ISO 222 standard, it's not something we're proposing. It's actually a standard that is being proposed worldwide to be adopted to address this issue in particular. Just have a richer data standard that can be used for cross-border communication. So now the next question is, why are we integrating this on the blockchain? And to Web3 native people, it might be obvious because we know the features that are possible, but I think it is important to highlight what is blockchain bringing to the table when it comes to streamlining transfers and streamlining payments. So I think the first thing is how easy it is to integrate with this standard, right? Like the way we did it, and Keen is going to dive deeper into it, is designed for a plug and play integration, not something that doesn't require a heavy development uplift at the beginning. So that's how we're addressing the entry point into it. The second thing, I think it relies on the smart contract capabilities, right? The ability to automate certain workflows, the ability to automate complex operations and make it so that they are curated and they can be repeated, and overall optimize operational efficiency. When I say operational efficiency, this goes anywhere between, having payments pre-programmed so that they are easy to be repeated, or we're going to talk about settlements as well and how can blockchain be used as a settlement layer. um, the other thing why blockchains are a good fit for this is the high transaction throughput, right? We talk about speed. In Coreum, I think we have a remarkable speed, and this is important when it comes to doing cross-border payments. It's the reason why we believe blockchain is the best option, because transactions can be done in a matter of seconds, and also it is very scalable, as we've seen up until this point with Coreum. So there's going to be one topic that we're going to touch on, for anyone that hasn't heard about smart tokens, is our flagship development, I would say. And it basically entails the capabilities of embedding business logic, like business features, into the token implementation so that we can have a lightweight execution of this business logic, which could be whitelisting, freezing, and we'll get into it later. So at this point, I wanted to pass it on to Keen so he can also give his take on how to explain smart tokens from a technical perspective, and continue with the presentation.
Yes. Can you hear me?
Yes.
Okay. So hello everybody. Nice to meet all of you guys in the audience right now. And so before I start, I will introduce myself. My name is Keen. I'm a smart contract developer in Coreum. So yeah, let me maybe share my screen and I will go over this. Give me 1 second.
For sure.
Okay, so I do this. Share. Okay, so you can see my screen, right? Can you see my screen?
Yes.
Okay, great. So yeah, let's go delve a bit deeper into this, into the importance of not only ISO but also the smart tokens, like Fabio mentioned. So basically, the goal here is to use the features that our smart tokens provide, to combine it with the ISO standard, so that we can do this kind of message transportation, this flow, ISO flow through the blockchain. So why do we use smart tokens? Well, smart tokens have like very interesting features. In the case of the ISO 222 standard, we're going to use the asset NFT, which are NFT smart tokens. So these smart tokens have the ability, have the feature to embed data into them, which is very interesting because the ISO, in the end, the ISO standard is a way to deliver messages to between financial institutions, right? So you can just imagine like a financial institution wants to talk with another financial institution with the ISO standard. Well, we can use these smart tokens to put this ISO information into them so that we can transport them using the Coreum blockchain. On top of that, the good thing about smart tokens is we can also use them inside the smart contracts, and like Fabio mentioned, program these workflows, these operations, automatic operations that each financial institution wants to do with a particular client, or maybe for a particular region. Imagine like a bank working in a specific region, so they have a different set of rules. So all these rules can be programmed inside smart contracts and also using smart tokens. Okay, so these are, if you're familiar with Coreum, you're probably familiar with smart tokens already, but let's also like do a quick overview about what we can do with these smart tokens. So smart tokens have, when you create a smart token, you have the ability to program into them certain features, right? So you can say, okay, this is going to be my smart token. I am going to allow minting of the smart token. So you can, all these features that you see on the screen right now, minting, burning, freezing, and whitelisting, these are features that you enable or disable when you create your assets. Additionally, you also have this kind of commissions and royalties, which are also very interesting because someone wants to transfer a token and a currency to someone else. It can automatically charge these kind of commissions and royalties for you without you needing to program them. It's already like the logic is already automatically applied. But let's focus more on ISO, not so much on smart tokens, because this presentation is more about ISO. So how did we tackle how do we plan to tackle this problem of, not the problem, how to implement this ISO standard using the blockchain? So as you can see on my screen, it says each ISO message is tokenized into a smart token. What does it mean? Like an ISO message in the end is just an XML. It's a long XML. You can see here like XML declaration. So that's the format, the format of the ISO message. It's an XML. So what we do is we encrypt this ISO message, because when banks communicate with each other, they want the communication to be private. In general, banks or financial institutions in general, they don't want to make their transactions public, right? They could if they wanted to, but in general, they don't want to, right? So they can have their public key and private key, and they can decrypt with the other financial institutions' public key and just send it to them, and then only that institution will be able to read it. So what we are doing here is we are attaching encrypted messages into the smart tokens that Coreum has. It can be a payment, it can be a report, a credit transfer, a debit initiation. So it can be any kind of ISO message that you want to send or that an institution wants to send. It can basically attach it to a smart token. So here we can see a general overview of how it works. So we have institution A. It can be a financial institution in general, bank A and bank B, right? And imagine the institution A wants to send a message, an ISO message, or wants to start a flow. with multiple ISO messages, like some sort of ping pong between them talking in ISO language, right? So basically what institution A will do, well, they will have their API, maybe like an external company, an external software, some like the Swift network provides an API. So they will do their internal process, which involves validating the message before they're sending it. And then what they're doing is, since the only institution B should be able to read this message, well, they encrypt it using the public key of the institution B, and basically they put it into a smart token. Okay. Then the smart token can be used to send it through the Coreum network using smart contracts, or without smart contracts if they don't want to apply any additional logic. And basically then the institution B can decrypt it and then do their internal validation. That's basically the general overview, and we will go more into detail when we're overviewing the simulator later. Also, like Fabio mentioned, we have smart contract capability on Coreum. So smart contracts open an endless range of possibilities. So let's say you want to add a custom logic to your ISO workflow, right? You can say, okay, for this client, for this financial institution that I'm working with, when I'm sending the smart token with the ISO message, I want this custom logic to happen. So, and for this other client, or let's say for this other region, for this other set of clients, for the other set of regions, I want to apply a different logic. So you can, as you know, Coreum is a permissionless chain. You can upload as many smart contracts as you want. You program your logic in them, and basically that's it. You have all these defined workflows, and you can decide how they are going to be executed and what they are doing in each of them. So we have a small graph here. We can see how we have the smart token at the very top, which contains, like I mentioned, the ISO message by institution A. And then it says, do you need custom logic? Well, if you need, then yes, let's use a smart contract. That's what they're for, right? If you don't need the custom logic, well, let's ignore smart contracts. We don't need smart contracts. Let's do the ISO message. And then we go to the next step, which means on-chain RTGS. So we are going to go more in depth in what RTGS means and how blockchains are ideal for doing this kind of gross settlement. But basically what RTGS means is like, I don't only want to send the ISO message, but I also want to send my funds with it. So on the blockchain, one big advantage that we have is that you can send a message and you can attach funds to it. So you can basically say, okay, here is this ISO message, and here are these set of tokens, or this token, which can represent, it can be US dollars, USDC, USDT, even Coreum, if someone wants to settle a transfer with Coreum tokens. So you have the option to add funds to your messaging, which is a big advantage, and we're going to go more into detail later on. And I think that's it for this PowerPoint presentation. So I don't know if you guys have any question. I can answer some questions now, and then we go into the simulator we have ready here. Any questions sorry. Any questions, Annalisa or Fabio, that you can highlight and I can answer?
Absolutely.
Yeah, I have one important one. I think we can just provide a little bit more context when it comes to the off-chain validation and how like banks are doing it right now. We're offering that possibility, right, to be able to, for example, use Swift or Tradeheader, like external validation
Yes.
software.
So basically, I mean, if you're a financial institution, you're already using the ISO 222. You're probably doing this validation already, right? So like you said before, we don't need to re-implement we're not going to have this heavy code lifting to integrate someone into using ISO on our network, right? They can still use this validation, because in the end, the ISO message has to be validated off-chain, because they want to keep it private, right? They don't want to send the public content, the content of the ISO message onto the chain, because then everybody will be able to see it. So they can, if they're already using an internal software or an external API to validate their messages, they can still use it. They don't need to overhaul their systems or change their way of working to integrate this on board.
We have another question here from Russell Bauman. What
Yes.
tokens can be added to the RTGS?
Well, any token, any smart token, it can be Coreum, it can be USDC, anything that you can issue and mint on Coreum, you can add it into a blockchain message. The funds, like any funds that you can hold in your wallet, can be used as a settlement currency.
Then we have Coreum Concepts asking, what advanced features would require an additional smart contract?
What advanced features with a kind additional smart contracts? So maybe he's asking an example of bank logic to require smart contracts. So let's say, for example, there is an ISO flow that says, okay, first I want to receive a payment. So if when I receive a payment instruction, I want to execute this smart contract. But then the next message, I want to decide, okay, if I receive an accept message, I want to execute this contract. If I receive a reject message, I want to execute this smart contract. And then basically inside a smart contract, you decide how you want to handle this. Like maybe you want to, if it's rejected, you say, okay, so if this is rejected, the funds that I initially sent, I want them sent back. Something like this is an example. I'm not sure if this was the question, but you can basically decide how your exchange of messages develops. You can decide what to do or what not to do. And for that, you can use smart contracts.
Okay, thank you so much, Kim. I think we can continue. And all the
Maybe
people
let me
in the chat.
zoom in a little, because does it look good like this? Can you see clearly my screen?
Yes, a little bit more, I think. Just to
Okay, like maybe like this?
Yeah, perfect.
Okay, great. So let's go into the simulator. I think we spent a bit too long on the presentation, but that's fine. So basically, here is an example of how an ISO, a real workflow would work. Okay, so here we have a simulator to simulate a real ISO workflow. By the way, if you want to use this, it's already available on our Coreum website. You just have to go to coreum.com. Let me refresh this 1 second. And here on an ecosystem, so 1 second, you can click on ecosystem and you have ISO 222. You click here and it will take you to this simulator. Okay. So imagine now, let's simulate a real ISO exchange between institutions, right? So first of all, we are going to create a wallet for each institution. So here we have one wallet. So institution A, in this case, you can see has the flag of India. So let's imagine it's a bank. It's a bank in India. And then here we have the flag of Poland, I think. Yes, Poland. So here they have both their wallet. Okay, we are going to fund it. We're going to fund both wallets. Okay. And you can see financial institution B, right now their wallet has 100 core and it has 0 USD. And this wallet here has 89.99 core and it has 11,000 USD. So before they start, they can communicate with each other. They have to exchange their public key with each other. So let's generate the keys. Okay, now both of them have keys. You can see, if you click here on view details, you will see that, well, this is the public key. So basically institution A will give this to institution B, and institution B will give its public key to institution A, so that they can encrypt the messages and send them to each other, right? Without anyone being able to read them. As you can see here, we have three different scenarios. Let's cover the first one. Is probably the most interesting one, which is ISO plus RTGS. So what does RTGS mean? RTGS is basically the settlement of the exchange of messages, right? If you just want to send ISO messages without any funds attached, when you can use the second workflow. This is basically the ISO confirmation or ISO rejection. These scenarios here, they don't attach any funds to the message. If you want to interact with another institution and also make a funds exchange, well, you can use this ISO plus RTGS. Let's click on it and let's go more in detail. Let's run. So you can actually come here and test it yourselves. You can click any scenario and click on run, and it will start running. Okay. So you will see here the exchange is starting. And let's go with the first step. As you can see, the balance was $11,000 before of institution A. So now it's 10,000. What does this means is it started a session. So this ISO session, the financial institution A decided to send $1,000 attached to the ISO message. So how does it internally work? Well, first of all, you can come here onto the, if you click on the link, it will take you to the Coreum Explorer and it will show you what exactly happened, but let's not go too much into technical details. So what it's doing here is like, first of all, it's creating a smart token with the ISO message in it. Okay, so first of all, it's creating the smart token and it's putting inside the smart token, it's putting the encrypted ISO payment. In this case, the institution A is sending a payment to institution B. So it's basically tokenizing this message. Okay, if we view the message, in theory, in a real scenario, we will never be able to do this. Only financial institution B will be able to decrypt the data and read it, right? But since this is a simulation, we allow you to view the content. So you can see here, this is how an ISO message looks like. So if you're familiar with XML format, well, you can see here it's an ISO 222, and it's a payment initiation. Okay, so this message here, we are encrypting it and we are putting it inside a smart token. And then we are sending the smart token to a smart contract. And the financial institution B, what it's doing is, oh, it's reading this, it's querying the smart contract and it's saying, oh, I received an ISO payment. Great. The bank will, well, the institution will read it and it will answer institution A. So for example, here, what institution B is answering, it is sending a, it's sending it by saying, okay, I accept, I received your message. So it's a payment status report. Okay, so basically what I'm sending you a report of what I received and I'm saying I accept it. So what you sent me, I accept it. And then it's sending two messages actually. It's sending this status report, and if you look here, it's sending another one. So basically, here it's sending a bank to customer debit credit transaction. Okay, so this financial institution B received one message from A, and then it sent back two messages to A. So you can see here, the first green box on the right is the first message received. And then these two green boxes on the left are the two messages received from institution B to A. And if you look here at the bottom, both of them, when the exchange ended, decided to confirm. What happens when both of them confirm? If you look at the balance of institution B is now 1,000. So what this is saying is this institution talked to this institution, so they both communicating using the ISO language, which is the standard, and they also transfer funds to each other. There was an RTGS done by the blockchain. The blockchain acted as an RTGS and settled this payment between each other. Okay, so this is basically how this is like a short workflow. There could be like many more messages exchanged with each other, but to showcase how it works, here you can see how we do it. Smart tokens, smart contracts, and the ISO standard all in one combined. Let's do a quick new session, but in this case, we are going to do ISO rejection. Okay, let's imagine two institutions talk to each other, but in this case, one of them doesn't agree, so they reject the session. Let's wait a little for all the things that are running in the background. So you can see here how, again, institution A started the session by sending a smart token with the ISO message inside of it to institution B. Well, to the smart contract, institution B queried the smart contract, sent two messages to institution A. Then institution A, in this case, it didn't end there. It sent another payment to institution B. But in the end, one of them said, sorry, this is not what I expected. This is not what we agreed. I reject this, and therefore no funds are exchanged. And this session, as you can see here on the left side of my screen, this session that the bank started is marked with a red cross. It means it was never, there was no agreement reached, so it was rejected by one of the parties, so this exchange was not valid. Okay, in the case of the first one, it shows a red green tick, and as I mentioned, the balance was successfully transferred because it was accepted by the parties. So this is pretty much how, in general terms, the ISO 222 flow would work using the Coreum blockchain. Again, we combine the capabilities of smart tokens, the flexibility of smart contracts, and the ability of a blockchain to transfer funds attached to these messages to make the settlement. So we combine three things in one. So before I go into the technical part of the code, maybe we can go another round of questions.
There is one question I would like to pull from the chat. Shout out to the tuber Q. They are asking if the message scheme is recorded on the Coreum blockchain, and if so, if institutions are able to privatize the tickets. From my understanding, I think that's encrypted. It is on the public blockchain, and they have the option to privatize it as well. But Keen, feel free to elaborate.
So I'm not sure, does he mean this message here, if this is on the blockchain?
I think he means just the transaction information.
Oh, yeah, the transaction information is on the block. You can go, actually, each transaction. So in this scenario, for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 transactions going on. Let's click on one. For example, the send message to institution B. Here we have the transaction. So it's on the blockchain, like this person asked. And this contains three messages. First, it's issuing an NFT class, which is basically a smart token. Then it is minting a smart token, and like I said before, it's adding this encrypted content into the smart token. And then it's executing the contract saying, I want to start a session, and the NFT smart token that contains the information that I want to send has this ID and this class ID. And I'm sending it to this address, which is the address of the financial institution B. So yes, everything is on the blockchain, but since when you mint this token, you are encrypting this message, nobody can actually read it except the person who has the private key, right? So that's why it's important to point out, like what this person said, like before you're sending this into the blockchain, you're encrypting it because you don't want anybody to read it because it's private information. So yes, the transactions are on the blockchain, and anybody can see them and look at the content of the transactions, but they wouldn't be able to understand the content because it's encrypted, and it's basically a bunch of characters that you cannot read, like don't make sense because it's encrypted. Right? I'm not sure if this answers that person's question.
Yeah, 100%.
Any other question? No? Then maybe we can go to the last part of the presentation. So basically, yes, we covered what the ISO 222 is. We covered the simulator, like how it works, how it would work, or how it currently works with smart tokens and smart contracts. Maybe let's take a quick look at what this in this scenario, in this simulator scenario, what the smart contract does. Very quickly, because I don't want to. Maybe it's a bit too technical. Let me zoom in a little bit here. Zoom in. Okay. So let's go a bit fast. So here we have messages. So basically what we are doing here, we have, for the ISO standard, we have 4 messages to interact with it. We have one that is called start session, which is the equivalent of starting a new session. The first, if you look at the Explorer here that I showed before, sorry, not this one. This message here is calling this smart contract entry point start session, right? So what I'm saying is I'm starting the session. This is the message. So the message is inside this NFT, which has an ID and a class ID. If you're familiar with smart tokens, you will know what I'm talking about. Basically, if you're not, it's just an NFT, an asset NFT. And the destination is an address, which basically where I'm going to send my, who I am sending this ISO message to. Once you start a session, you can also attach funds to it. Like this message in this case, let me go back here. This is the one that was rejected, but let's go at the one that was not rejected and go to the Explorer. You can see, I think in the first round of questions, someone asked me, can I send any funds? And for example, here in this one, we attach USD. But for example, here you could attach Coreum. You can attach euros if you have euros. You can attach any kind of token, currency, blockchain currency that is available on the Coreum blockchain. So basically, you start a session and you say, okay, I'm starting this session and I'm sending this initial ISO message with this amount of funds into it, attached to the message. Sorry. And then basically, the institution B will start communicating. This will create a session ID, which is here. So the institution B will be able to query and will say, okay, let me see my active sessions. Did anybody start a session with me? I can query the contract and say, okay, I have this session open. If you go to session response, I have so many sessions open. So anybody can basically send a message. Well, not anybody. The institution can answer that session with another ISO message. So basically there is these two entry points. Well, these two execute messages. Start session and send message are what we saw in the simulator in this part here, where they start to ping pong each other, sending messages to each other, right? Once they are done, they have 2 options. They can confirm the session and they can cancel the session. So basically what this is doing is, okay, I confirm my session. Now I need to wait for the other party to also confirm the session. Imagine the other party doesn't confirm the session, but decides to cancel the session, which in our simulator looks as rejected. Well, the funds that I initially attached to this message will be sent back to me because the session is not confirmed, it's canceled. Let's imagine the financial institution B doesn't confirm the session but leaves it there forever. Well, there will be a timeout, of course, and if you don't, for example, imagine you can, like someone ask, what can we program into the smart contract? Well, you can add a timeout. Let's say I want to send an ISO message, and if I receive no answer from the institution in 10 minutes or in 2 hours, this session is automatically canceled and my funds are sent back to me because there is no settlement to be done, right? So yeah, that's how it basically works. You can here, I'm not going too much into this because it's just a bunch of code, but basically that's the general view. Like, you start a session, you send messages to each other, and in the end you confirm a session or you cancel a session, and that's what we see in our simulator here. And that's how a real workflow would work for a financial institution. And they can define as many contracts. This is just an example, right? They could define 100 smart contracts, 50 smart contracts. Okay, for example, for this specific address, I want to do this. And then basically here in the contract, we will have, okay, if the address I'm sending to is a specific client I have, well, we are going to do this. If not, we are going to do this. And you can call other smart contracts, and then, well, it can become more and more complicated or more advanced depending on your business operations or your business necessities. So I need to drink some water. And I think that's pretty much it. I think we covered everything we wanted to cover. We are right on time, if I'm not wrong. Maybe we can go with the last round of questions, or maybe Annalisa or Fabio, you have any other questions you want to ask or anything to point out?
We do have one more question for the tuber queue. Would both institutions have to hold Corium to be able to approve and process the ISO messaging scheme with each other?
So both, if they're going to use the Corium blockchain, which they are because we're showcasing it, they need to have enough core to at least spend the gas, right? Because each of these transactions, they cost gas on the Corium network. So if you remember at the beginning of the presentation, institution A had 90 core, and institution B had 100 core. You can see how these balances have changed a little. This one now has 89.94, and this one has 99.93. Why did it go down? Well, every time they execute a transaction on the blockchain, they need to pay gas. So Corium is used as gas on the chain. So answer to your question, yes, they will need Corium, at least enough Corium to cover the transaction fees, right? Additionally, imagine one of them, instead of using USD, they want to use core to settle their payments. Well, they would need the core to do those payments, right? But at least they would need the core to execute the transactions, which here they didn't need much because we didn't do many. But imagine a financial institution that is going to send 1,000 transactions per hour or 1,000 transactions per day. Well, they would need a lot more core to cover those fees, right? So yeah, they would need core, of course.
Thank you, Kim. Thank you, everyone. I think we want to hear from Fabio some last words as well.
Okay, let me stop sharing.
Yeah, no, I just wanted to say thank you everyone for joining. I saw one last question that I just wanted to use it kind of for the ending message, which is, which problem are we ultimately solving, right? So I think ultimately there's two things that are being addressed here. One is just the compatibility, so that like institutions that already have working payment structures, right? They have a system, and they want to interoperate with Web3 projects, or they want to also use blockchain as a settlement layer, like Keen showed us, to transact with other institutions. I think that's the problem we're solving, and we're tackling the speed, the security. But this is a real problem right now. There's institutions that, especially when you're talking corporate to corporate or corporate to bank, not necessarily central bank. Central banks is going to take a bit longer, right? They do have this issue. First, their systems might not be as compatible. Second, they would have to go through traditional rails would might take 5 days or even 6 days to settle a transaction. So this is just providing a way for them to transacting value online easily and securely. So ultimately, that's what we're solving. I hope you guys enjoy this presentation. As always, we're open to onboarding new institutions, not only institutions, it can be also SMEs into this pilot program of just adopting this standard and then showing the results. That's the approach we're taking. So I believe in Q2 we'll be able to showcase some results that compare, for example, ISO 222 on Coreum to other traditional system and payment networks. And that's ultimately the approach we want to have. We want to have results first. That's why we deploy this simulator, which clearly showcases how it works on the blockchain with real transactions. So having said that, thank you everyone for joining. This is one of many workshops. We're going to keep doing this, and always we appreciate the feedback. So if there's a topic you want us to dive deeper into, leave it in the comments, and I'll see you on the next one.
Thank you, Keen. Thank you, Fabio. We have one last question. This is more technical. It goes to Keen. Does this mean that all non-compliant financial institutions can use the Corium blockchain through some type of API to transact with each other and make themselves instantly ISO compliant?
Well, I am a bit confused by the. Can you hear me? Yeah, I am a bit confused by the question. Like, make them instantly ISO compliant. So basically, uh, to be ISO compliant, you need to send. You need to be able to generate like valid ISO messages. Like, mm, we are going to. We provide a way of sending those messages. Like, we are not going to be an API to validate the ISO messages. I'm not sure if this is your question. If you remember at the beginning of the presentation, we had a slide where we saw that the institution used an API, an external provider, either Swift or internal software to validate those ISO messages. And once those messages are validated, they send them to another institution. But that's something that financial institutions already do. Like, they are communicating with other institutions using the ISO message. If they're not doing that, well, they're probably not financial institutions in the first place. So yeah, like, no, we're not validating ISO messages. I think I'm a bit confused by the question because I'm not sure what he meant, but we are allowing institutions to transfer, to move from traditional systems to a blockchain technology to transfer ISO messages. And those ISO messages are already valid because they're already talking to other financial institutions, but they have their own software or other or external APIs to do that.
Thank you, Keen. And again, thank you to the audience. Please don't forget to like, subscribe, and share this workshop. And subscribe to our YouTube channel, of course. Follow us on social media, Twitter, Instagram, our Telegram and Discord as well. We are highly active on those channels. We have really big news coming as well. We just launched a new partnership with leading educational institutions in North America. Corium has partnered with the University of Calgary, Blockchain Association, and the University of California, Irvine Blockchain Association. So go ahead to our Twitter, check out the new press release detailing all of these new partnerships. And if you are a student, also check out our student ambassador program, soon to be launched later today on our social media channels. Have a great day, and don't forget to like and subscribe to our YouTube channel. Thank you.
Goodbye, everybody.